So guys, welcome back to another video of our analysis. So today we're going to understand what exactly went wrong on a flight 9 with the both our protagonists, the booster 14-2 and ship 35. Well, I'm really going to like returning into the analysis of it because SpaceX is officially has announced and uploaded the real causes of the both vehicle failure. So today we're gonna know about them and study with a bit information to see what exactly went wrong with our precious flight vehicles that we will never forget them in our life. So the Flight 9 was very the fiery, the roller coaster of the emotions because that moment I just held my breath to see if it going to pass the Seco or not because the second engine cutoff moment was the precious for the Block 2 versions even though there was a many of the failure happened in the block 1 but there wasn't any failure recorded regards to the seekers. That's why I was very excited for the flight 9 and I got the entire flight as a successful in my perspective because I'm not saying that failure is a part of the negative outcome. I'm saying there is a positive outcome to improve the data and improve the future. So let's see what exactly went wrong with our precious vehicles that we going to denote today. So let's start this. The first thing that we have to see from the booster because the booster was the precious the first stage. Without the booster, the starship cannot go space. So the booster is our priority in the analysis. So let's see what exactly went wrong with the booster 14-2. This is a Block 1 class booster. Is usually used for the first stage as a Starship fully integrated configuration. But the booster for in Dash 2 wasn't a like new booster and the fresh booster in its of its kind when actually performed in a flight 9 because the booster for in Dash 2 was already performed is the flight in a flight 7. If you didn't know and if you don't know, then you can see and check out the flight 7 and see the profile of it. The flight 7 there was a booster 14 as a brand new booster who like who performed the flawless maneuvers even though it caught by the Mikazilla arm successfully without any problem. So booster 14 is actually the reuse booster. I mean, it's actually going to reuse in a flight 9, but is actually used in a flight 7. That makes the something wrong because in a Starship program, this is the first time happened that we go into and we did the reuse the booster that never happened before. That's why that was the first attempt to do this anything like this. So the booster footing dash 2 was performed is the ascent flawlessly in a flight 9 without any problem without losing the single engines and for the compensation of the failures. But after the hot staging and flip maneuver, it started to perform is the experimental task that is scheduled by the SpaceX, including the high angle of attack, re-entry, plus the engine out scenario in a landing stage. So these all the experimental tasks was a state and the included for to test the entire boundary of the booster performance and entire structural loads integrity. That's why the booster for Dash 2 was already compromised from the first flight season. The Flight 7 introduced the new structural issues in a booster for Dash 2. That's why the SpaceX operated the booster for Dash 2 as experimental vehicle in the flight 9 is not go. That's why they did not schedule to catch the booster for Dash 2 in the flight. So they instead of catching the booster, they just operate like a experimental thing. So experimental subject. So after the flip maneuver, the booster for Dash to perform the flawless controlled re-entry without any compromisation because booster for Dash was performing flawlessly. If you're seeing the data, there wasn't anything off normal. In a high angle of attack, almost like a 70-degree of the inclination of the at the angle that the booster for Dash to perform. Wow, that was insane because that angle is completely introduced the new structural strain and the high re-entry pitches and peak the thermal load on the entire the booster stainless body. But despite that, the booster 14-2 still made out intact to the re-entry, and then it's it was almost it was almost the perform the re I mean the landing burn before is going to blast off. I mean, just like it's going to perform the landing burn in the last stage, obviously the splashdown in the offshore zone that's called the Gulf of America. So in that offshore zone where the booster 14-2 was performing is the landing zone, landing a maneuver. That moment something went wrong. The SpaceX noticed that some high energetic event happened at the aft section of the booster. Aft section is the engine section of the entire booster. So that on that section, the SpaceX noticed that something went wrong and that caused the entire booster catastrophically blasted in the air before it's going to ignite its all engines. So telemetry data lost along the booster physically, and that's why it's exploded over the Gulf of America. But what exactly went wrong with the booster protein dash 2? Despite its performance through the re-entry with the high angle of attack was very good, but there is a catch. If you don't know what is a compromisation, if you don't know what is a corrosion in the sense of the engineering, then you can't catch that nuances because if you saw the booster, I mean if you've seen the booster put in the history, there was a already marked history, the already marked flight means the booster 14, not the brand new booster, honestly the flight 9 moment. So that's why the booster 14-2 already underwent some the high load structural stress in the re-entry phases of the flight 7, and even though it's just the cat caught by the Mikazilla arm which introduced some internal structural issues, and these kind of the structural weakness made the internal transfer tube weaken. So what is a transfer tube? Transfer tube is like a the tube that is moving the fuel and cryogenic fuel from the like upper tank to the lower tank, and even the through the for the our engines. So these that's the actual the transfer tube just collapse under the high strain event of the entire transonic. So when the transonic happened, the booster 14 transfer tube did not manage to withstand that the force that actually introduced that moment, then is the collapse under the entire load and structural load and into the just lost in collapse. That's led the entire methane and LOX intermix. When it intermixed, then it exploded on the point. It just ignited unintentionally. So that explosion was intentionally ignited, wasn't a plant. So that's why the SpaceX newly upgraded some of the transfer tube inside the booster 4, booster 16. I guess I think they are really going to perform the once again the similar objective with the booster 16 to see if it survived through the really, yeah, if it could survive through the entire experimental task. So with the booster 14-2, we really saluted for the entire sacrification for the brand new block 2 versions. So that's why they made the thick and the longest uh, transfer tube for the block 3 versions to withstand that high strain of the forces during the re-entry and angle of attack. This is a very new challenge for the entire booster integrity because it's a sheer of mass and weight and entire parameter. But let's move towards the our second spacious stage, which always make us sad, often make us sad because the starship is not just the main character in a starship program; it's just another uh, like main hero in an entire moment because the ship 35 was one of the vehicle that like one of the block 2 class vehicle performed the flawless seco the second engine cutoff, and that moment we held the breath like a oh my god, what the hell gonna be happen, it's gonna be explode, it's gonna be lose engines, it's gonna be citizen engine unintentionally. That moment was quite challenging for me because I was really under stress and BP was spike up. That's why the Ship 35 was amazing. It won at the entire seco. But before the sequel is going to happen, there was some anomaly occurred that the SpaceX noticed, but we did not. We did not actually, because we don't have the data, we don't have the lens that actually seeing entire inside the ship 35. So let's see what exactly happened with the some stages. The first stage is the ship 35 ignition and activation. So after the hot staging happened, the ship 35 managed to ignite is the all engines and it started to ascend and climb to the its intended suborbital phase. But one thing is quite challenging and off nominal there, that after the ignition, the something happened wrong because the SpaceX detected the unintentional pressure build up in a nose cone section and pressure drops in the CH4 tank later in a 5-minute ascent climb. But with that, the drops and the pressure increase, the the Starship handle well and actually perform the sequence flawlessly. But with that, the uneven pressure distribution inside the Starship was introduced the new attitude control issues because the the pressure actually drops and the buildup inside the nose cone and payload bay due to this leakage in the nose cone section, and the CH4 tank was actually pressure drops due to the fuel diffuser. Okay, for the contacts, what is a fuel diffuser? Fuel diffuser is kind of the can with the multiple holes. It actually controls the even distribution of the pressurization inside the tanks. Means if the pressure is coming down linearly, it just distribute in a 360 degree. So it just not the letting the pressure linear drops in, is actually letting the pressure unevenly distribute in every corner of the tanks. That makes the pressurization, original pressurization, even efficiently good and fast. That's why the fuel diffuser failed to maintain the pressure, and that led the drops in a pressure in a CH4 tank, the methane tank. And here is a three-factor contributed the failure of the ship 35. Three-factor, only three-factor you can understand easily. The first, the CH4 uh, tank pressure drops in. Second is the nose cone pressure builds up, and third is the undeployed payload bay, like payload housing. Let's see the one by one. The first, the CH4 tank pressure drops in. So let's understand by this entire physical uh, uh, demonstration. So just think it like a starship. So when the pressure drops in a CH4 tank, it's going to the unevenly on a angle. So when the pressure builds in the nose cone section, then the starship orientation will lean towards the forward. So with that uneven weight distribution, the entire thing is just collapse under the failure of the single diffuser, and the pressure builds up in the nose cone section. But the Starship is trying, let's try and hardly tried to maintain the and vents out the exceeded pressure inside the nose cone by the nose cone vents, but that did not help us because the Starship hold the thrust control systems. These are helps to the control the pitch and roll of the Starship orientation. These are not designed to withstand the many and the several uh, like orientation deficiency. That's why we almost here to hear that the Starship is just not the failed by ski or fuel diffuser or leakage inside the methane, because there is a main role play. The CH4 drops in, nose cone pressure builds up, and the third point is a very main point, because the Starling simulators are housed inside the nose cone bay, which introduce the uneven pressure there, like uneven weight distribution. So means the high weight and high pressure, and inside the uneven weight distribution is just deficient in like directly towards the nose cone. So it leads the high tumbling and jiggling inside in an orbital suborbital phase. So to compensate that, the thrust control systems hardly tried, but they not designed to withstand the several orientation deficiency. That's why I'm just said this is a real problem in a starship, that every single failure can introduce the new problem. That's why the orientation failed collapse and thrust vector controls tried hard, but they are not efficient to manage, and that led the attitude control failure. And at the T plus, yeah, at the T plus 35 minutes in the counting, Starship started to re-enable is the venting of the nose cone section, but that did not help us a lot. But during the re-entry, the Starship is just re-entered with an uncontrolled manner, did some the uncontrolled re-entry maneuver over the Indian Ocean, and we saw some lighting dancing of the usual casual starship falling apart in a re-entry forces and in a plasma. That's what exactly went wrong with the Starship Flight 9. Ship 35 demise was totally sacrificed for us. The flight 9 and everything, flight 10 and everything was just scheduled like we were expected, but nothing goes as we planned. But partial success is not the uh, like is not leaning towards the failure. It's actually leaning towards the success because we can actually do it. Because SpaceX is already have under tested the fuel diffuser system once again to see. Let's see if that upgraded fuel diffuser system will work well or not. Hopefully that should be work because we are anticipating a lot for the flight 10. How the C-37 will perform well in the flight 9, flight 10. I'm hoping for that. But so my name is Gaudruchi. You are watching another directory, and let's see, flight 10 will be happen on the 24th August. I'm really hopeful to see that. And wow, let's see if it go past to the 24 August window or it will be delayed once again. Let's see the ship 37 and booster 16 pair on the pad and stacking them and light up the candle and go for the launch. So bye guys, I'm Edison the Possible.